All right, so for the first couple of the review, we have to prove that these are equal. So we're going to rewrite everything in terms of sine and cosine. So secant is the reciprocal of the cosine. So we have 1 over the cosine squared of x minus tangent is sine squared of x over cosine squared of x equals 1. So one way we could do this is we could fraction bust. We could say let's multiply everything by the cosine squared of x. So if we distribute, now it's 1 minus sine squared of x equals cosine squared of x. And we know this as a Pythagorean identity. If we added that sine squared of x of each side, we'd have 1 equals cosine squared of x plus sine squared of x. So we are good at this step if we recognize that's Pythagorean identity. So this next one, what can we rewrite? Well, I see this, sine squared plus cosine squared. I know that's 1. So I'm going to rewrite that as 1 over tangent sine squared over cosine squared plus 1 equals cosine squared of x. Well, somehow we need to simplify this fraction. So we need to make a common denominator down here. So 1 over sine squared of x over cosine squared of x. Plus, we could rewrite this as 1 is cosine over cosine equals the cosine squared of x. So now we have 1 divided by sine squared plus cosine squared over the cosine squared of x equals the cosine squared of x. Well, we know this part is 1, so it's 1 over the cosine squared of x equals the cosine squared of x. And to divide this, we keep our numerator and then we multiply by the reciprocal. So the cosine squared of x over 1 is the cosine squared of x. So we've proved it there. And then this last one, tangent. Well, tangent squared, sine squared of x over cosine squared of x times the cosine of x, not squared, just the cosine of x, divided by, that would be 2 over the cosine of x, equals 1/2 sine squared of x. Well, let's erase this here. So let's see, what can we simplify? Well, cosine and a cosine. So this becomes sine squared of x over cosine of x. We could multiply by the reciprocal, so times the cosine of x over 2. Those reduce down to 1, so we have 1/2 sine squared of x. So this is really sine squared of x over 2, which that equals 1/2 sine squared of x. So we've proved it there. These next couple are dealing with the double angles. So let's see. Number 4, we're told it's in quadrant 2. So there's our triangle. Cosine adjacent over hypotenuse. So 4 over 5, and this would be a negative. And we could do the Pythagorean theorem here. -4 squared plus whatever y squared equals 5 squared. But I recognize this as a 3, 4, 5. And then the sine of 2 theta. Well, this is on our desk here on the formula sheet. So that's 2 sine of theta cosine theta. So 2 times our sine, opposite over hypotenuse, 3/5, times our cosine, -4/5. Multiply our numerators, 2 times 3 is 6 times 4. So we have -24/25. And then we have the cosine of 2 theta. Our formula for that is cosine squared of theta minus sine squared of theta. So our cosine, -4/5 squared, minus our sine, 3/5 squared. So we have 16/25 minus 9/25. So that's equal to 7/25. And then our tangent, that's not on our formula sheet, but we know tangent is sine of 2 theta over cosine of 2 theta. So let's see, -24/25 divided by 7/25. So we have -24/7. So this next one's similar, except it's in quadrant 3. So here's quadrant 3 and sine opposite over hypotenuse. So 2 and 3, this would have to be negative. And then that Pythagorean theorem, negative 2 squared plus x squared equals 3 squared. So 4 plus x squared equals 9. So if x squared equals 5, this would be root 5, and it would have to be negative. So sine of 2 theta, 2 sine of theta, cosine theta. So 2, our sine is negative 2/3. Cosine adjacent over hypotenuse, negative root 5 over 3. Multiply across, so it's going to be positive 4 root 5 over 9. And then we have the cosine of 2 theta. So again, that was cosine squared minus sine squared. So our cosine, negative root 5 over 3 squared, minus our sine, opposite over hypotenuse, squared. So if we square this, we have 5/9 minus 4/9. So that equals 1/9. And then the tangent again, that is the sine over the cosine of 2 theta. So that would be 4 root 5 over 9 divided by 1/9. So that is just 4 times the square root of 5.